you are carrying this bag using the rope, these two ropes here, the question is you should find this tension, that is the force that is on the ropes. So the first thing you need to know here is that the tension in the two ropes is going to be equal. Whatever tension that is found in this first rope will be found in the second rope. Then, how do you solve this problem? This problem can be resolved by using a triangle method of vectors, because these three vectors are in equilibrium. And what are the three vectors? The three vectors include: one is the weight of this object acting downward, then the force on the first rope, and the force on the second rope. So we can represent this thing in a triangle. So we can represent the weight of this object acting downward by a tiny line. This tiny line now is the weight of this object, and we have our weight to be 60 Newton. So what we have here is 60 Newton. That is the weight of the bag. Then we are told that the first rope is inclined at what angle? At angle 70 to the what? To the vertical line. You can see the vertical line. So, and this force here is a vertical line as well. So the first force is inclined at 70 degrees. So this is my T. And the second one is also inclined at 70 to the vertical. So this is another 70 here. So this is my T as well. So having done that, we can find the angles inside this triangle 40. So this side, the angle here is 40 degrees. Then if you look at this triangle, we say that this triangle is what can be called an acute angle triangle. Why? Because none of the angles here is equal to 90 degrees. So it is an acute angle triangle. If this is an acute angle triangle, what is the best way to solve it? What you simply do is you use the sine rule. So I'm going to use sine rule here to resolve the problem. And I hope you still remember how sine rules are written. Sine rules are written as A over sine A, capital A, to be equals to B over sine capital B, to be equals to C over sine capital